In this problem, an audio transmitter T and receiver R are hung vertically from two identical massless strings of length 8 meter with their pivots well separated along x-axis. They are pulled from the equilibrium position in opposite directions along x-axis by a small angular amplitude theta naught is equal to cos inverse 0.9 and released simultaneously. If the natural frequency of the transmitter is 660 Hz and the speed of the sound in air is 330 meter per second, the maximum variation in the frequency as measured by the receiver due to receiver is, take the acceleration due to gravity as 10 meter per second. Right. So what the problem says here, this not a completely simple harmonic motion, the pendulum concept and Doppler effect. Right. Let us take this one. This is x-axis horizontally. Two pendulum are here, well separated along x-axis. So both are having length 8 meter. They are dragged, pulled in opposite direction like this. So one is I may say one is transmitter, this is, and this is receiver. So in Doppler effect, this is the source, this is the observer, like that. Okay, so they are pulled and left. So when this both are making the same angle theta naught. So whatever we discuss for the transmitter, same will be correct for true for the receiver. So when we just pull and leave it, so it will come, this is the L length, that is 8 meter. This is the pivot, L minus H length up to here, and this is the height H, it has moved up. So when it comes down H height, the velocity of this source, I may call it as a source, velocity of source. Why? Because transmitter is transmitting signals. What the formula we know? When it comes to the mean position, the maximum velocity is 2gl into 1 minus cos theta. So let us substitute values. 2 g is given as 10 into length is given as 8 meter into 1 minus, so cos inverse, that means theta is equal to cos inverse 0.9. So this is 0.9, right? So that is equal to root of 2 into 10 into 8 into 0.1. So now this 10 and this will cancel each other. 8 2s are 16. So I will write here root 16, that is equal to 4 meter per second. This is the source velocity. What's the data given there? The data given here, sound velocity they have given, v is equal to 330 meter per second, and also the natural frequency of the transmitter given, so n naught natural frequency 660 hertz. This is what they have given. See here, when this transmitter and the receiver are oscillating like this, when receiver and transmitter comes like this close, the frequency, apparent frequency increases. When they go away, when they recede, then the apparent frequency decreases. So we have to calculate the difference between the maximum frequency and minimum frequency. When they come close, maximum. When they go back away from each other, the frequency, apparent frequency decreases. This is what happens according to Doppler effect. So Doppler effect formula, let us write. So first of all, I will write the maximum frequency. When do we have maximum frequency? When receiver and transformer approaching each other. In other words, when the source and the observer are approaching each other. So that is n max is equal to, if not I will write here, when transmitter and receiver approaching each other, then we'll have maximum. What is the formula? N naught V plus Vs by V minus Vs. This is the formula. Let us substitute the, okay, we will write the formula. Next one is, secondly, what happened? Both T and went away. So when T and R are receding, or they are going back, or separating each other, then apparent frequency decreases. N minimum is equal to, so N minimum formula, apparent frequency, real frequency into V minus Vs by V plus Vs. Vs is for source velocity, V is the velocity of sound. So what we've been asked in the problem, the difference in the frequency. So N max minus N minimum, we have to calculate. Let us write the formula. N naught comes common. Between these two, N naught will come common. So here V plus Vs by V minus Vs minus V minus Vs by V plus Vs. So LCM, N naught, what is the LCM here? V minus Vs into V plus Vs. It is V square minus Vs, Vs square. So A plus B into A minus B. Here this will become V plus Vs whole square minus V minus Vs whole square. Right. So here this formula also we know now. This is similar to that one. So real frequency A plus B whole square minus A minus B whole square is equal to 4AB. 4V into Vs by V square minus Vs square. So now let us substitute the values here. That is equal to N naught. What is the natural frequency? 660 into 4. What is V? Velocity of sound. So 330. What is Vs? Source velocity. How much it is? 4 by. What is V? Velocity of sound. So 330 square minus source velocity square. So here I will do a small approximation so that I can get the answer quickly. What I do? 660 4 into 330 into 4 by, see, when we compare the 330 square with 4 square is very less. So this 4 square I will neglect. Right? Then I will have only 330 square. So 330 will go here, 331s, 332s. So how much I get here? This is the delta n. 4 4s are 16, 16 2s are 32 heads. So approximately equal to 32 heads. This is what our answer is. So for 16, question number 16. Yes, this is question number 16. The correct answer is 32 heads.